Okay, let's dive right in. We're talking about something genuinely groundbreaking today in robotics, this new humanoid robot, the Walker S2. And the buzz seems to be around this idea of it running, well, almost continuously.
That's right. We're looking at UBTECH's Walker S2, and specifically this really innovative feature it has, autonomous battery swapping. It sounds kind of simple, maybe, but it addresses a huge bottleneck in robotics, basically, power. How long can these things actually run before they need help?
Right. So let's break it down. What exactly is this Walker S2? Give us the basics.
Okay, so Walker S2, it's a humanoid robot, looks kind of human-shaped, arms, legs, torso, bipedal. Comes from UBTECH, a Chinese company. They've been pretty active in this space for a while now.
UBTECH, yeah, I've heard the name. And this S2 model, it's brand new.
Very new. Launched just this month, July 2025. The promo videos started popping up online, YouTube, and places like that. Around mid-July, maybe the 17th. So yeah, it's definitely current stuff.
Got it. And physically, what are we looking at? Size-wise, is it imposing or?
It's actually pretty reasonably sized for operating around people. It stands about 5'3" tall. That's roughly 162 centimeters. And weight-wise, it's 95 pounds or 43 kilos. So think like a smaller adult human in terms of dimensions. Not tiny, but not massive either.
Okay, 5'3", 95 pounds, manageable size. And what's powering it? You mentioned batteries.
Yeah, it runs on a dual battery system. Two 48-volt lithium batteries. Standard sort of tech there. Now, endurance on a single charge, it's decent, but, typical. Can walk for about 2 hours continuously.
2 hours walking.
Or stand still for maybe 4 hours.
Yeah.
But the key context here, the thing to remember, is the recharge time. If you were to plug it into the wall using a cable, a full recharge takes about 90 minutes. 1.5 hours.
90 minutes. Okay, so that's the baseline downtime if you do it the old-fashioned way, which really highlights why this autonomous swapping is such a big deal, right? This world-first feature.
Exactly. That's the core innovation here. It's the first humanoid robot, they claim, that can perform a fully autonomous battery swap. And we're not just talking about plugging itself in. This is the robot physically removing a battery and inserting a new one, all by itself.
Wow. So how smart is it? Does it just swap when the battery gets low, or is there more to it?
There's quite a bit more, actually. It actively monitors its own power levels, obviously. It knows when a battery is running low. But it also senses if a battery is overheating, which is important for, safety and hardware life. And here's the really clever part. It makes decisions. It doesn't just blindly swap.
Decisions? Like what?
Like, based on what it's currently doing. Is it in the middle of a critical task? Is the task high priority? It decides whether to swap right away or maybe wait a bit.
Yeah.
It might decide it has enough juice to finish the urgent task and then go swap, or maybe swap one battery now and keep going. It's managing its energy for optimal uptime.
That is sophisticated. It sounds almost strategic. So walk us through the actual swap. How does it physically do it? I'm picturing fumbling robot hands.
Hey, well, the footage makes it look surprisingly smooth, actually. Very precise. So first, the robot identifies it needs a swap and navigates itself to a dedicated charging station. It's not random. It positions itself very accurately, often backing in, facing away from the station.
Okay, facing away. Why?
Because the battery pack is located on its back. So it uses its arms, which are quite dexterous, we'll get to that, to reach behind itself. It then unlatches and removes the depleted battery pack, pulls it right out.
Okay.
Then it takes that spent pack and places it into an empty slot in the charging station. That slot isn't just storage, it immediately starts recharging that battery. Right after that, it locates a fully charged battery in another slot in the station, grabs it.
Using its own hands, its manipulators.
Exactly. Picks up the fresh pack, and then very carefully aligns it and inserts it back into the power port on its back. Clicks it into place. The whole thing is choreographed. Precise.
And the time. How long does this whole maneuver take? That's crucial.
That's the kicker. The entire exchange, from approaching the station to having the new battery in and being ready to go, about 3 minutes.
3 minutes. Compared to 90 minutes for a cable charge.
Precisely. You see the difference. It's massive. It almost eliminates power downtime.
That's incredible. So what's the tech behind that? How does it achieve that level of precision and autonomy? It can't just be brute force.
No, definitely not. It's a combination of really refined hardware and some very smart software. First, you've got the limbs themselves. These aren't simple grabbers. The Walker S2 has 20 degrees of freedom.
20 degrees of freedom. Explain that a bit.
Right, so that means it has 20 independent points of movement or rotation across its body, especially concentrated in the arms, wrists, hands. Think about all the ways your own arm and hand can move. That high number allows for really fine-tuned, human-like dexterity. It's needed for delicate tasks like lining up the battery connector perfectly, applying the right amount of force, lashing it.
So the arms are physically capable. What about knowing where to move them so precisely? Sensors.
Absolutely critical. It's packed with sensors. LiDAR is a big one. Light detection and ranging. That creates a super accurate 3D map of its surroundings in real time. Millimeter accuracy. So it knows exactly where it is, where the station is, how to align itself perfectly.
Okay, LiDAR for the big picture positioning.
Then you have stereo vision cameras. Like our eyes, they provide depth perception and detailed visual info. This allows for something called visual servoing, basically, using live camera feed to make tiny adjustments to its arm movements as it gets closer to the battery or the slot, like how you subtly guide your hand when reaching for something fragile.
Real-time visual correction. Makes sense.
And finally, proximity sensors. These give very precise short-range data, almost like a sense of touch right before contact. They help fine-tune that last little bit of movement for a perfect insertion, making sure everything slots in smoothly without force or damage.
So LiDAR, stereo cameras, proximity sensors, all feeding data constantly.
Yep. Monitoring everything, scanning for obstacles, ensuring that perfect alignment for the swap.
But hardware is only part of it, right? The software must be doing some heavy lifting here.
Oh, massively. The software is really the conductor of this whole orchestra. UBTECH has developed its own proprietary AI software. They've been working on this stuff for years, honing it. It's not just running a fixed sequence like an old factory robot. It's adaptive. It processes all that sensor data, makes the real-time decisions we talked about, when to swap, how to adjust movements if something's slightly off. That autonomy is software-driven.
And safety. Handling batteries, moving parts.
Right.
There must be safety measures built in.
Definitely. Safety is paramount. The software includes fail-safe routines. If it detects an unexpected obstacle, or if the alignment isn't quite right during the process, it'll halt the operation immediately, pause, reassess, maybe try again slightly differently, or just stop safely if needed. Prevents damage to itself, the station, or anything nearby.
That's reassuring. And you mentioned it has 2 batteries. Is that just for longer runtime, or is there more to it?
It helps with runtime, sure, but the dual battery system is also a crucial redundancy feature. Think of it as a built-in backup. If one battery pack suddenly fails, or maybe its performance degrades unexpectedly,
It can just switch to the other one.
instantly, it prevents a single point of failure from shutting the robot down completely. This massively boosts its reliability, especially if you're planning to run these things 24/7 in a critical environment. It ensures continuous operation even if one power source has a glitch.
So redundancy, safety, precision sensors, dexterous limbs, smart software, it all comes together for this 3-minute swap. And it can still charge via cable if needed.
Yeah, the option is still there. If the swapping station isn't available for some reason, or maybe for maintenance checks, you can still plug it in. But obviously, that takes the 90 minutes. The autonomous swap is the standard preferred mode for continuous operation.
Okay, this really clarifies why it's such a leap. It tackles that fundamental power problem head on. You hear, robot changes its own battery, and it might sound simple, but the implications are huge. This potentially run forever idea.
Well, maybe not literally forever, but the goal is achieving true 2047 autonomous operation. For years, the story with mobile robots, especially humanoids, has been great capabilities, but they run out of juice. They need humans to tend to their power needs.
Right, someone's got to plug them in or swap the batteries manually.
Exactly. And that human intervention limits everything. Efficiency, how many robots you can realistically deploy, the cost effectiveness. It's a major constraint. Walker S2 basically cuts that cord, removes that human dependency for power.
Now, battery swapping itself isn't brand new, is it? I feel like I've heard about it for EVs or maybe some warehouse bots.
You're right, the concept exists elsewhere. Some electric cars have swap stations, though that's often attendant-operated or requires specific infrastructure.
Yeah.
And yes, some automated guided vehicles, AGVs, and warehouses might swap batteries, but those are usually simpler, wheel robots operating in very controlled environments, often needing specialized, fixed docking machinery.
So the breakthrough here is the humanoid robot doing it itself, using its own dexterity.
Precisely. It's the full autonomy, combined with the humanoid form factor that makes it a first. It doesn't need a complex, custom-built swapping rig for its specific shape. It uses its own general purpose, limbs and sensors, to interact with a relatively simple charging station. That flexibility is key for deploying it in more diverse places.
And the efficiency gain is just staggering. That 97% reduction in downtime, going from 90 minutes to 3 minutes.
It's a game changer for any application where uptime is money, which is, well, most industrial or commercial applications. Think about a factory running 3 shifts. If your robot needs a 90-minute charge break every few hours, that's a significant chunk of lost productivity across the day.
You'd need more robots just to cover the charging breaks of the others.
Right. Or you accept a lower overall output. With a 3-minute swap, the impact on workflow is minimal. It can duck out, swap, and be back on task before you barely notice. This makes deploying robots much more economically viable and reliable for continuous tasks. It really underpins the whole 24/7 operation concept.
It changes the calculation entirely, so it's less like a tool that needs constant tending and more like a self-sufficient worker almost.
That's a really good way to put it. It shifts the perception and the reality from sophisticated tool needing care to self-sustaining worker. The potential for efficiency gains becomes enormous when you remove that primary need for human intervention for power.
And frees up human workers from that routine task.
Exactly. Humans can focus on higher-level tasks, problem solving, quality control, managing the overall system, tasks that need human judgment and creativity rather than just plugging things in. It's like comparing a machine you have to manually top up with fuel every hour versus one that refuels itself. The management overhead drops dramatically.
Okay, this is making a lot of sense. The what is the autonomous swap. The why is continuous operation and overcoming power limits. Now let's talk about the where. Where are we actually going to see these Walker S2 robots put to work? The sources mention factories and maybe customer service roles.
Yes, those are the initial target areas UBTECH is highlighting. In factories, you can easily see the benefit. Precision tasks, assembly line work, logistics, things where continuous operation boosts productivity. And the customer service angle is interesting too. Meet and greet roles in public venues, information kiosks. Its humanoid form makes it suitable for interacting with people.
And that continuous operation means it can be on duty all day, potentially.
Right. But UBTECH's ambitions seem to go much further, especially looking at their partnerships. They have a major collaboration with Huawei, the tech giant. And their stated goal together isn't just factories in China, it's also putting humanoid robots in homes.
In homes? Wow, that's a big leap from a factory floor.
It is. It suggests a high degree of confidence in the robot's safety, reliability, and crucially, its autonomy, including this power management. You can't have a home robot that constantly needs you to plug it in or swap its battery.
True. Has this been tested in real-world scenarios yet, beyond lab demos?
Yes, there have been significant trials. One notable example is at Zeekr's smart factory. They make electric vehicles. They deployed multiple Walker S2 robots working together in a 5G-enabled environment. So not just one robot, but a fleet coordinating tasks.
Multiple robots working together.
Yeah.
How does that coordination happen?
Through a cloud-based system UBTECH calls BrainNet. Think of it as a central AI command center. It gathers data from all the robots, coordinates their movements to avoid collisions, assigns tasks based on priority and robot availability, manages traffic flow, essentially orchestrates the whole fleet.
So BrainNet is the intelligence layer.
And the autonomous battery swapping is the physical endurance layer. The sources explicitly say this swapping is key to enabling that 24/7 operation in these complex multi-robot factory settings managed by BrainNet. The system knows which robot needs power, directs it to a station, while keeping the others working efficiently.
That paints a picture of a truly automated ecosystem. Okay, so manufacturing, maybe customer service, potentially even homes down the line. Where else could this never needs to stop? Capability be truly transformative, especially thinking about its humanoid form, being able to navigate human spaces.
That combination continuous operation plus the bipedal humanoid form opens up a lot of doors where wheeled robots just can't go or aren't practical. Think about hospital logistics, for example.
Hospitals, complex layouts, stairs, busy corridors.
Exactly. Imagine a Walker S2 delivering medicines, lab samples, or supplies autonomously within a hospital. It can navigate hallways, maybe even use elevators or stairs, operate 24/7 without needing manual charging breaks. This could ensure critical supplies are always moving, reducing delays in patient care, especially during off hours or staffing shortages.
That could have a huge impact on healthcare efficiency. What else?
Disaster response is another powerful potential application. After an earthquake or a flood, power infrastructure is often down or unstable. Search and rescue is critical but dangerous.
And time limited by human endurance and safety concerns.
Right. A robot like Walker S2, capable of swapping its own batteries, perhaps at a mobile base station or pre-positioned charging points, could operate for much longer durations in hazardous zones. It could continuously search collapsed buildings, map unstable areas, provide real-time data back to responders, all while minimizing risk to human life. Its persistence could be invaluable.
That's a compelling image. Persistent robotic search and rescue.
And then there's the whole area of warehouse sorting and fulfillment centers. We touched on factories, but high-volume warehouses are another prime candidate. These places often run 24/7 already, pushing for maximum throughput. A humanoid robot that can continuously sort packages, manage inventory, move goods without shift changes or charging downtime.
Could drastically increase efficiency and speed up deliveries.
Absolutely. It fits perfectly with the trend towards more automation in logistics and e-commerce fulfillment. The continuous operation is the real draw here for those high-volume, time-sensitive operations.
And you keep coming back to the bipedal form being an advantage in these scenarios.
Yes, because it allows the robot to operate in environments designed for humans, not just flat, open floors, perfect for wheeled robots. Stairs, uneven surfaces, cluttered workspaces, narrow aisles. A bipedal robot can potentially handle these much better. This broadens its applicability immensely. It doesn't require redesigning the entire environment for the robot. The robot adapts to the human environment.
So hospitals, disaster zones, warehouses, factories, the potential applications are really broad once you have that combination of humanoid agility and continuous power. This does raise a bigger question, though. If we start seeing widespread deployment of robots that truly never stop, that can navigate our spaces, manage themselves, what are the broader societal implications? Positive, negative?
It's a huge question, and one we'll likely be grappling with for years. But fundamentally, the core takeaway here is that this autonomous battery swapping capability is a major step towards truly self-sufficient robots. It moves them beyond being just machines limited by their power cords or battery life. They become persistent actors in whatever environment they're placed in.
It removes a fundamental leash, in a way.
Exactly. It unlocks a new level of automation potential. The focus now shifts, perhaps, less on just keeping robots running and more on what they can do, how smart they can be, how they interact with us safely and effectively. It's about moving from solving the endurance problem to tackling the next layers of intelligence, adaptability, and integration into society.
So for you, our listener, think about this. What tasks in your own daily life, maybe at your workplace or in your industry, could be completely changed, maybe even revolutionized, if you had access to a robot that genuinely never needed to stop for a break or a recharge? It really makes you think about where the limits of automation might lie in the future.
It certainly does. It's a significant milestone.
Well, this has been incredibly insightful, a fascinating look at the Walker S2 and what autonomous power management really means for the future of robotics. Thanks for breaking it all down.
My pleasure. It's definitely technology worth watching closely.
And thank you for joining us for this deep dive. Hopefully this gives you a solid understanding of this potentially game-changing development.